I've done it a few times. Not something that I plan to do, just forgot. All right. So, is it here? Nope, it's under my downloads folder. So unzip to get to those two files. So q67 answer.zip. It will give you 3 files instead of 2, because one of the questions I have 2 answers. Like question number 6, I'm giving you 2 potential answers. All right. So with question number 6, let me show you the original code first, because that would be helpful. This is x2/q6.cpp. Let's just look at the original question first. Okay, so this is the original file, and your job is to fix this program so the swap subroutine, which is here from line 8 to line 15, it will work to exchange the values of 2 members, I and j of v1. v1 is of a struct x type, and struct x has 2 members. One is member I, and the other one is member j. So by calling swap, I want to exchange the 2 values. I want j to have the value of 2. I want I to have the value of 23. That's the objective of the swap subroutine. And you can see that the way I call swap is to specify the v1.I, which is member I of v1 as the first parameter, and v1.j, which is member j of v1 as the second parameter. The way it is right now is not going to work. Okay, so let's try to analyze why it is not going to work. And we're also going to take a look at things kind of from the perspective of the compiler, because as much as we don't want to think like a compiler, a lot of times it is a necessity to kind of think and look at things from the compiler's perspective. So what we'll do is we'll start with the subroutine swap itself. It takes 2 parameters. The first parameter is px, and the second parameter is y. Okay, so let's try to answer 2 questions related to the first parameter px. What is the type of px?
This is a pointer.
It's a pointer to an integer. Okay, it's a pointer to an integer. So that's the first question. The second question is it passed by value or is it passed by reference? It is passed by value. Okay, because we don't see the ampersand in the parameter, it is passed by value. All right. Did someone knock on the door? Maybe not. Okay. Oh, okay. You were erasing something. Okay. So this is passed by value, but it is a pointer to an integer. And then we'll take a look at y. What is the type of y? Parameter y. It is just an integer. Okay. Y as a parameter is just an integer. The second question is it passed by value or is it passed by reference? It is passed by reference because we can see the ampersand symbol here. So these two, passing either as a pointer or passing by reference, they accomplish about the same thing. Okay. In many ways, you can call these 2 methods as quote-unquote equivalent method because one can be used to implement the other one, or more or less. But the way you refer to the parameters is going to be different. Okay, so look at line 12 here. I'll look at line 12 and tell me what is the type of t.
T is an integer.
T is an integer. It's a local variable of type integer. Okay, very good. And once again, what is px? It's a pointer to an integer. All right, so now we have a problem because on the right-hand side, px is a pointer to an integer. On the left-hand side, we have just a regular integer. The types do not match. Okay, a pointer to an integer is not the same thing as an integer. And the compiler cannot do automatically typecasting in this case so that one side becomes the same as the other side. So that's why it won't work. The compiler will complain on line 12 and say that the types of the 2 sides of the assignment operation, they do not match. Okay. Same thing is going to happen on the next line here because px equals y. Once again, y as a parameter is of type integer. The fact that it is passed by reference has nothing to do with it. Okay, we're still looking at just the type of the parameter, which is integer. And px is a pointer. And once again, on one side we have a pointer, on the other side we have just a regular integer. The types do not match, and there are no automatic ways to make them match. Okay, so there's no promotion method to make them match. This line is going to be okay. Line 14 is going to be okay because t is an integer, so is y. And so we can use on one side, on the right hand side we have an integer, on the left hand side we also have an integer, and that's not going to be a problem. Okay? So this is one of the reasons why we have a problem here, but there's also one other reason. When you look at line 23, when we call the subroutine swap, what is the first parameter? What is v1.I? What is the type of it?
Part of the structure.
It is a member of a structure, right? But what is the type of that particular member?
Integer.
It is an integer, okay? But this argument is going into a parameter px here, which has a type of a pointer to an integer. So on line 23, the compiler will also complain and say that v1.I, or the first argument, does not match the type of the parameter because we are now trying to pass an integer to a pointer, and that conversion cannot be done automatically. Are there any questions about the problems of the original code? No questions? Okay. Even if there are no questions, I'm going to compile this code here. So I'm going to open up another terminal, or I can just reuse one of these other ones already here. And we'll just go ahead and compile G++. I'll just use a -c here to compile. I'm not going to run the program because it's not going to succeed in compiling anyway. Okay, it complained about three problems. Okay, exactly 3. And once again, the first one is on line 12, which is this one here, and it complains about the conversion, invalid conversion from integer pointer, which is the right hand side, to integer, which is the left hand side. It cannot be done automatically. On line 13, it's the reverse. On the right hand side, we have an integer. On the left hand side, we have an integer pointer. And once again, that conversion cannot be done automatically, and the compiler complains about it. The third problem is on line 23. It says invalid conversion again, okay? And this time it's from integer to integer pointer again, because v1.I is an integer, but parameter px is a pointer to an integer. So once again, we cannot do the conversion automatically. The last error is initializing argument 1 of void, and it is on line 8. And I think, okay, these two are basically the same problem. One line is referring to the call itself, the other line is referring to the definition of the subroutine. So it's giving you a pretty good clue of which two lines are involved here, because oftentimes you can fix one or the other. You do not usually need to fix both lines. Okay, so this is great. Okay, we know what the compiler is going to complain about. We know the nature of the problem. So now let's think about how to solve the problem. There are at least 3 ways to solve this problem. Okay. All right. So let's take a look at the first way to solve the problem. We'll go ahead and copy the original code to q6a.cpp, which may or may not correspond to q6a in the file that I distributed earlier. Okay. So we can either fix the way it is called, or we can fix the subroutine itself. Well, we have to fix the way it's called anyway. Okay, I take it back. We can either fix the subroutine or fix the way we call the subroutine. So either way, it's going to work. Okay. Usually, what people do is to change the subroutine itself so that the way we pass the 2 parameters is consistent. Okay. So either you use pass by pointer or you use pass by reference for both parameters. Because when you're dealing with swapping, it is the same thing, right? I mean, there should not be any change or any difference between the way you pass the 2 parameters. Yes?
It would have to be px because px is the...
Well, I'm going to change the rest too. Yeah, because I don't want to use px because the p as a suffix or prefix means that it's a pointer.
Oh, that's why.
Yeah. Well, that's my own little convention. If I use a pointer, I use a little prefix. So that way I know from just reading the name of of my parameter or local variable, I know it is a pointer. Yep.
Isn't it a pointer because of the asterisk and not the lowercase p?
That is correct. But when I want to use p as a prefix in the name itself, just so that because if I just look at the name of a particular parameter or name or a local variable, I want to be able to tell kind of right away what is the type of it. Some people they go even more further. They use like pi for pointing to an integer and then the name of the actual variable. But I just use a p to indicate this is a pointer because that part is very important to me. So from here on, the rest of the fix is easy because every time I refer to px, I just have to change it to x, and that's going to work. Are there any questions about the first way to fix this program? What about line 23? Is it going to work now?
Yes.
Yep, that's going to work because I have just changed the first parameter of swap to a pass by reference parameter, but it is of the type integer, so it is matching and everything is going to be okay. All right, well, just to be sure. Yep, go ahead.
Just a quick question.
Mhm.
On line 19, it says struct x, so it's calling onto the subroutine of struct x.
It's not a subroutine. Struct x from line 2 to line 6 is the definition of the structure.
Mm-hmm.
So what it's going to do is, remember, this is a cookie cutter. I'm defining a cookie cutter here, and now I'm using the cookie cutter to cut out a piece of cookie.
Okay.
And on that piece of cookie, we have two parts. The first part is the I part, the member I, and the second part is the member J, and each one has a different value.
Okay. So it's kind of defines the V1 itself, the cookie cutter.
The cookie cutter is the type of V1.
Okay.
Yeah, every time you define a cookie cutter, you can use it as a type, so that you can basically stamp out variables using that cookie cutter.
Yeah, I got this. Thank you.
Mm-hmm. Yep.
Is there a reason why you declared the structure as a global? Or
You cannot define a structure as a local. It doesn't really, well, I guess in certain cases, you might have a need to define a structure locally, but for the most part, structures are used across multiple subroutines, so they cannot be local. I don't think C allows you to do it locally. You cannot define the structure as a local thing inside the subroutine. All right, so let's go ahead and make sure the compiler is okay with this too. So we say G++-C Q6A CPP, and it is compiling just fine. Okay. All right, so what about the other way, or the other two ways of fixing this problem? So let's look at Q2B, which is the other way to fix this program. So with Q2B, I'm going to fix Y so that it is also a pointer to an integer. So I'm going to change it to a pointer to an integer. So to do it this way, I need more changes. Because the first thing I would need to change is how we call swap. Because v1.I is an integer, but px is a pointer to an integer. So what do I need to do here to turn an integer into a pointer to an integer, or the address of an integer? There's one operator that can turn a variable into the address of the variable. Not percent, ampersand, yep, that's right. Okay, ampersand here, and ampersand here as well. Now, this is the part that you have to be careful. The question is, are we swapping the pointers, or are we swapping what the pointers point to? What the pointers point to. So that means I don't really need to know what is px. That's not what I want to store into T. I want to store what px points to. The value pointed to by px is what I need to know. And what I need to change is not the pointer itself. It is what the pointer points to. Okay? So this is important because if you do not do it the right way, and instead, because sometimes people try to fix this in a different way. So let me just kind of revert back to the old code here. And sometimes people look at it and go like, oh, okay, remember y is not py. Okay, let's fix that. That's an easy one because the compiler will catch that. Okay, So sometimes people look at this and go like, oh, okay, since the compiler is complaining about the type of t not matching the type of parameters px and py, one wrong way to fix this program to make all the types match is to turn t into a pointer also. Okay, this will shut up the compiler too. The compiler will not complain about this because now t, px, and py, they are now all pointers to integers. But what am I really doing here? I'm swapping the pointers. The pointers are basically quote unquote the same thing as local variables. In other words, you can do whatever you want with the pointers, but it doesn't do a single thing to the actual argument. In this case, it doesn't do anything to v1.i or v1.j because I'm just playing around with the call numbers. Okay, so that's not going to be helpful. It's not going to crash the program either. Okay, because I'm not even dereferencing. I don't even care what the pointers point to. I'm just saying, okay, you get this, I get that, and we're all good. Okay, are we doing okay so far with this? Why this is not going to work? But it will make the compiler, shut up, because it's not, there's no problem anymore.
Can you just give me an example, like using analogy for why that wouldn't solve the problem, just to better understand it?
Because a pointer, because we are not doing a single thing about what the pointers point to.
Okay.
So that means, the subroutine swap is not going to touch the values of v1.i or the value of v1.j. But the objective is to swap those two values, right?
Yeah.
So if you're not touching the value at all,
it's not doing
then you cannot be doing anything useful to the value itself.
Yeah.
Okay? So this is not the right way of doing things. So what we'll do is to say, oh, we need to refer to whatever the pointers point to. Okay. So another wrong way to fix this problem is to say, we'll just put an asterisk in front of everything. Here, 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 and here. Once again, the compiler is going to be saying, oh, this is all good because the types all match up. Because whatever t points to, whatever px points to, and whatever py points to, they are all integers. Okay? So we have integers on one side, we have integers on the other side. All three assignment operations will succeed. But this one is going to crash. Okay? This one's going to crash because let's look at line 12 first. Okay? The right-hand side of line 12 is whatever px points to. That's not going to be a problem, because the way we pass to px is the address of v1.i, and v1 is a real thing, it's a real local variable, so v1.i does have a location to store an integer, and we are just passing that location along to parameter px. So px will point to an actual place that you can store an integer, not a problem. Okay, we can dereference this one without any problem. What about t? T is declared as a local variable, so it should be okay. Well, once again, I'm not storing something to local variable t. I'm storing something to what t points to. Okay, the asterisk in front of t is dereference, which means, okay, I'm going to use t as a call number, and then I go to the library according to the call number, and that location in the library is where I'm going to store something. Okay, where do you think t is pointing to at this point?
Outer space.
Outer space is not a bad analogy because it is not initialized. Okay, any local variable that is not initialized can be pointing to any location in memory. So that means this t is going to be pointing to some location, which you would hope that it's pointing to outer space, because if by accident it is not pointing to outer space, you'll be accidentally changing the location of some place or something in your program, and you probably have no idea what it is. Okay? So that means it's not going to work. Line 12, the way it is not going to work. So to fix this program is to say, oh, okay, this is not supposed to be a pointer. It is just a local variable of type integer. Okay? Now we still have no problem because t is an integer, and then whatever px points to is also an integer. The right-hand side, the left-hand side, they're both integers, and it's going to work. Are we doing okay so far with the second way to fix it? Okay. Do you guys understand why the previous two fixes will not work? The one that changes everything to pointers and just swap the pointers, and the one that dereference all the pointers. Neither of those is going to work. Okay. And with those two, with those two incorrect way to fix this program, you can actually use the debugger and run the program. Okay. With the first one, you can see on line 14 or right after line 14, you will see the pointers exchanged, but the values pointed to by the pointers will not change. Okay, you can actually see that in GDB. With the second way to fix it, it will crash on line 12 because T is uninitialized, and it will attempt to store to a location that is not, that your program cannot access. Okay, so I encourage you guys to actually do that, just so that you can see the symptoms of doing it the wrong way, so that you have a better understanding of why they're not supposed to work. But this is supposed to work, so we'll go ahead and G++ double check q6b.cpp, and it is compiling without any problem. I should be running it too, so let's go ahead and run it too. So G++-C-G, because we want to include debug information. And we'll go ahead and link it to q6b, oops, 6b, q6b.o, and gdb q6b. It's the program, put a breakpoint on line 23, run the program. Now we're on line 23, okay? There are several things in GDB that I want to demonstrate here. I want to demonstrate what is V1. V1 is a structure, and let me just make the screen a little bit shorter like that so the people in the back can see it. So V1 is a structure. It has two members. The first member is I, has a value of 2. The second one is member J, it has a value of 23. Okay, that's fine. We know that part already. We also want to look at what is ampersand v1.I, the address of member I of v1. Okay, it's this number here. Can someone kind of guess what is the address of J? We're dealing with 32-bit integers here. Not 71. 32-bit means 4 bytes, right? So assuming it packs everything contiguously, it's going to be a 7-4, not a 7-1. Okay? So we'll take a look at the J, and it is 7-4. Now this part is not always the case. The compiler does not guarantee to pack things the most compact way. Okay? So with a 64-bit platform, the compiler can decide and say, I want everything to go by 8 bytes. Okay? And there's no way you can say, oh, but you should be using it this way. No, there's no such a thing as this is the right way to pack it. It's just whatever the compiler decides. Okay, but remember these two numbers, because when we single step into the subroutine, you can see that when we single step, it says that px is now this particular address. See how it is now matching the address of v1.I, and py is this address here, and that is also matching the address of j. Okay, so we'll go ahead and single step through swap itself, single step, and single step. We're now ready to return from the subroutine. So if I look at px and py, should I see any changes? Just px and py, the pointers. Should not, right? So if I say print px, print py, you can see the pointers have not changed. When I first got in, px has this value. I'm just about to exit now. It still has the same value. It is still pointing to the same place. When I look at y, same thing. Okay, y started off with this address, and this is the end. It still has the same address. But the question is, what about the content that they're pointing to? If I look at whatever px points to, it is now 23. But it used to be 2. And if I look at whatever py points to, that should be 2 now, because the exchange worked. So if I single step one more time, I will go back to the main subroutine right before the return. But at this point, I can print v1 again, and you can see how the values of two members have now exchanged. Because they used to be, 2 used to be here and 23 used to be here. If I just go back earlier, you can see that's the initial condition before the call to swap, and that is the new condition after the swap. So are there any questions about how this works? No? Okay. So the pointer method is definitely more prone to user error, okay? Because you can see how I can mess up the code, okay, in 2 different ways. And the compiler cannot catch the problems. The compiler can probably catch the second way of wrong way, because I'm dereferencing T without first initializing T first. So the compiler can catch that one, but barely. Okay. Still, it is very error prone. It can lead to problems. Yep.
So, looking at this problem, just intuitively, we'll be able to look at your call for a void swap, where you had asterisk px, %y. It's like, okay, well, this isn't matching. You need to make them match.
But they don't necessarily have to match, because the objective is to exchange the 2 items in the structure.
Right. Right.
Yeah.
So
they don't have to match, which means that I'm going to give you q6c as the 3rd solution. Okay. So do you guys have any questions?
You just was wondering about which way was the correct way. I was just telling you that there's multiple ways.
Potato, And now we have a potato, which is the 3rd way. Okay. All right. So the 3rd way is not to change the subroutine at all, and just change the way we do things inside the subroutine, and also how we call the subroutine. Okay, so we are not changing the parameters. Okay, so this is the 3rd way to quote-unquote fix the program. Probably not the most desirable way to do it, but it will work nonetheless. All right, so what we'll do is we'll go ahead and say we're not changing the types of the parameters. Okay, they're gonna work. But when in the subroutine here, whenever we refer to px, we have to add a dereference, because px is a pointer to an integer, and we have to refer to the value, the integer that it points to, and not the pointer itself. We'll do the same thing here. Okay, once we fix this, we have one more thing to fix here, because on line 23, we are still currently passing an integer to an integer pointer px, and that's not going to work. So what we'll do is we'll refer to the address of v1.i instead of just v1.i, and that will make the whole thing work. Okay. Now, if you look at this subroutine swap, it gets the job done, but it's not the best way to do it, because you can see that the 2 parameters should be kind of symmetric, but they're not. Okay. But this is a good illustration of how passing by pointer or passing an address is really functionally kind of the same thing as passing by reference. Okay, so we'll go ahead and take a look at this program here. Okay, we'll go ahead and compile, and this time I'm going to compile. I will combine the compiling and the linking into one just to save some time. It does not generate any error. Now you want to try the warn all also, and tick, and even with that, it's not complaining. If you really want to check, you can also turn on optimization, which will also include flow analysis, and even that is not complaining. So we are pretty sure that the compiler cannot find anything wrong with this program. So now we'll go ahead and gdb the executable, list the program, put a breakpoint on line 23 again, run the program all the way up to line 23. We're just about to call swap. Print v1, same thing as last time, no surprises here. Now, when we single step, you can see and say, hey, it's almost the same thing as last time. Okay, px has an address and y also has an address, but you can see how the 2 are displayed slightly differently. Okay, with px, it simply displays, oh, I have this address here, but it does not tell you what is at that address. Because with a pointer, sometimes it can be an invalid pointer pointing to some la-la land. So the compiler or GDB says, okay, let's be safe here. I'm not even sure that this is actually a valid location. I'm not going to tell you what is at that location. On the other hand, y being passed by reference always need to be referring to a valid location. And that's why the notation is slightly different. It says y is at this location and it has a value of 23. Are we kind of doing okay so far with the notation? How in GDB they look different already. And yet they're about the same. Okay, both are actually addresses. So we single step, single step, single step. At the end here, we want to look at whatever px points to. It is now 23. It used to be 2. And then we look at y. It is now 2. And you can see how the pointer itself or the address itself has not changed. It's the same here, but the value has changed. The value at that location has changed. So this is the third way to fix it, which is not the best way to fix the program, but it does work. Okay? So are there any questions about Q1A, B, or Q6, A, B, or C that we have just kind of talked about?
Just a quick question. So the big X has nothing to do with the structure, right? When you just have the pointer?
That is correct.
Just a different
Neither
variable.
X or PX or Y or PY
It's a variable.
has anything to do with the structure itself, because what we are doing with those parameters is we're either passing an integer, which is a member of the structure. We're either passing it by reference or we are passing the address of that into the subroutine. The subroutine has absolutely no need to know about struct X
Instead
whatsoever.
of X, I can put any other variable that can work.
Say again.
Instead of that X, I can put anything there and still work fine.
Right, it can be any integer. Yep, it can be any integer. So I'm going to pass the row sheet right now. All right, so that's question number 6. Let's take a look at question number 7. Okay, so here's question number 7. And question number 7 is, if the program prints the output of 1:53:12, what has to be the input? That's the question, okay? So that means, you have to locate, where am I printing in this program? The only line in this program that prints something is on line 20. Line 20 is the only line that has a cout that will print something. And what we are printing will be the member hour, the member minute, and the member second of t. Okay? So somehow we have 1 stored in hour, we have 53 stored in minute, and then we have 12 stored in second in the structure t. The structure t is defined here. It is just a structure of time. It has hour, minute, and second as members, and they're all just regular integers, nothing too special here. Okay? So in order for t to have those values, it has to be something that was done before line 20. So we'll take a look at line 19. Excuse me. Line 19 is a call to a subroutine called second to HMS, should have been called seconds in plural, but it is just a unit conversion. So this is a subroutine defined on line 8 all the way up to line 13. It takes 2 parameters. The first one is just seconds passed by value or reference.
Value.
It's passed by value. The second parameter is a structure time, and it is called t. It is passed by reference this time because we see an ampersand here. Okay, so that means t, whatever we do to t is going to affect the original item because t is a reference to a particular structure. Okay, so we can see that in the subroutine we have 3 lines of code. Each one is going to change one particular member of t. Okay, the first one is hour, the second one is minute, and the third one is second. And the way we change hour, minute, and second is based on some kind of calculation of seconds. Okay, all right. So we know pretty much for sure that this is the reason why t has these specific values. Okay, 1, 53, and 12. What about seconds? Well, seconds got its value from the cin statement here. So this is whatever you type on the keyboard when you run the program. It has to be a particular number, and that number is going to be passed as a seconds as a parameter. And so the question really is asking, what are you going to type? What is the number in seconds that will make 1, 53, and 12 appear in hour, minute, and second in the structure? That really is the question. So What do you think? How do we approach this particular problem? Okay, there are several ways to look at this. Okay, one way to look at this is to say, okay, let's see how we can get a 1. Okay, don't even look at the cases that we're dealing with here. Simplify. Okay, when you try to understand something, think of more boundary or extreme cases. 1, 0, those are all boundary cases. Okay, so the first question is, how can I put a 1 into hour? What does seconds need to have in order to store a 1 into hour? What do you think? 3600?
Yeah.
3601, 3602, those will all end up with a single 1 stored in hour, right? Because with the division in C and C++, it automatically only takes the quotient after a division. What about the fractional part? What about the decimal part or the remainder? It's chopped off. Okay, we're only keeping the quotient. So if you think about what you need to divide by 3600 to get a 1 as a quotient, it can be 3600 all the way up to 7200 minus 1. Is that making any sense? Because it's only keeping the quotient. Okay, well that's good. Okay, so that means seconds has to be a number from 3600 up to 7199. Is that making any sense? All right, cool. Minute is probably the most nasty one. Okay, so let's skip that for now. Let's think about seconds first. Okay, seconds is or second as a member is based on seconds mod 60. Okay, remember the percent symbol means modulus, or we are only paying attention to the remainder after a division. Is that okay? All right, so the question now is, how can we end up with a number, let's say just 1, as the result of something mod 60? So let me just write it on the whiteboard. You don't have to write it down because it's really kind of basic math here. Okay, so the question is, what can I put here so that if you divide that number by 60, we'll end up with a remainder of 1? 61 works? Give me another one. Would 1 work? Yeah. 1 is going to work. 61 is going to work. 121 is going to work. 181 is going to work, right? So if you look at all these numbers, what is the general pattern? It's 1 times some kind of n as an integer times 60. Is that okay so far? So if whatever we have here as the dividend is 1 plus a multiple of 60, it will still give me a remainder of 1. Is that making sense? Okay. How is that going to help us here? How is it going to help us here? Because we know that second as a member has a value of 12.
So you want the remainder of 12?
So we know it is 12 plus some multiple of 60, right? Okay. So that's really helpful. Okay, so now that we know this part, so we know that hour equals to 1 means it is a number from 3600 to 7199. Is that okay? Now that's a lot of possibility. I mean, in fact, we have exactly 3600 possibilities here. So which one is it? Well, let's see if the rest can help us a little bit here. So this one means our mod, oops, take it back here. Second is the 12 means seconds mod 60 is 12. Okay. Okay. So that's not completely nailing down the value that we are dealing with here. So that means this line here on line 11 is kind of pivotal. Okay. So we are first dividing seconds by 60, and then we use the quotient of that division and mod it with 60 also. And the result turns out to be 53. So instead of thinking about 53, which is not a very natural number, easy number to think of, let's think about 1. Okay? So how can I make this particular expression give me a value of 1? what has to be in seconds? 60 is the easiest one, right? What about the next one? Okay, first of all, okay, let's roll back a little bit. Does everybody understand why, if seconds is exactly 60, then the expression will give me 1? Because 60 divided by 60 is what? 1. And 1 mod 60 is? We just looked at it. 1. Yes, okay. So what is the next one? Okay, so if you think about the end result having to be 1, it means this particular expression has to be 1 plus some integer times 60. Okay, so this expression itself has to be 1, 61, 121, 181, and so on. Okay. Oh, but this expression is really just seconds divided by 60. So if I want the quotient itself to be 1, 61, and so on, that means the original number has to be 1 times 60, 61 times 60, 121 times 60, and so on. Is that making any sense? Okay. So that means for seconds divided by 60, the whole thing mod 60 to be 53, we need, I'm just putting inline comments here to explain how to get that value. So we need seconds divided by 60 to be 53 times n times 60. Okay, plus, excuse me here. Okay, so it has to be 53 as a remainder times n times 60, because all of those numbers will give us a remainder of 63 when we divide it by 60. Okay? Oh, okay, but that's not too difficult, because now we can just multiply both sides by 60 to get to the actual seconds. So that means seconds has to be 50, okay, in parentheses, 53 plus n times 60, and then the whole thing times 60. Is that part okay? This is kind of algebra. Is that part okay? More or less? Okay. So now we have a few things that we have in place here. Okay, so this one, if I express it in some other way, this means seconds has to be 1 plus some kind of n times 3600. Okay, we'll call it n1 here. We'll call this n2 here, and here we have n3. So that means seconds has to be 12 plus n3 times 60. Okay. All right. So now we have to solve for n1, n2, and n3, and then come up with seconds. Okay. What do you think?
6,792.
Sorry?
6,792.
Okay.
I think it's you're making it too difficult than what it really is.
No, I'm not. There's no one single answer. See, that's the thing. This question has no one single answer. There are multiple numbers. In fact, if you don't count the representation of numbers, like there are only 32 bits, there's an infinite number of answers that can give me exactly the same result. Nah, never mind. That's not the case. Because the reason why I cannot say that is because this one is not even modded, so that's why it's limited. Okay, so we have. Okay, this part is wrong actually. So this is 1 times 3600 plus a number, and that number can go from 0 to 3599. Okay, that is the right way to look at it. Okay. All right. So we know there's a 3600 here, and the rest of these two have to account for this part here, from 0 to 35. 35.99. Okay. If you look at this one here, it will work even if n3 is a 0. Okay, so, okay. And if you look at this one here, it will work even if n2 is a 0, so we have to solve for the n2 and n3 have to combine so that this number is still from 0 to 35.99. And there's one more limitation here too. This n2 also has a limitation to it. Because if they're all bounding what seconds is. Okay. Because we're dealing with the same number here. Seconds can be expressed in this form, seconds can be expressed in this form, and seconds can also be expressed in this form here. Okay? Alright, so let's deal with this one first. Okay, so seconds is oh, by the way, there's another component here. The last one is from 0 to 59. Okay. All right. So if I carry out the multiplication, so now we have 53 times 60 plus n2 times 3600 plus another number from 0 to 59. The reason why I can have another number here is because I have first a division by 60, and that means it can have a component from 0 to 59 and still give me the same quotient. Okay. What about n2 here? What do you think n2 can be? No, can only be 0, right? Well, n2, no, it's not 0, it is exactly 1. Because this number, which can go from 3600 to 7199, has to be exactly the same thing as this number here. This part here combined with this part here is not 3600. So that means the 3600 has to come from this component here, which means n2 has to be exactly 1. Okay, so n2 n2 has to be 1, which means seconds is going to be 53 times 60 plus 3600 plus a component that is from 0 to 59. All right. So once we have this form, this one is easier because now we can say seconds is 12 plus n3 times 60. And this number can be expressed as 60 times something, right? Because if you reverse the distributive law, you can combine it back into one. Oops. So now we can say this one is seconds. So, okay, right here we can solve n3 first. So n3 is 60 plus 53, which is 113. So that means seconds is 12 times 113 times 60, which is the final answer. Oh, 12 plus, yes. There we go. So if you leave it the way it is, like this, it is still going to be okay. Because this is not a class on arithmetics. And see how quickly you can carry out a 5-digit by 5-digit multiplication. It's about can you solve the equations. Are there any questions about this? Yep.
I looked at this yesterday and just looking at your question, and not even looking at the code.
Yeah.
I was able to solve it very fast. And that's the number I gave you was a 6792.
Yeah.
If we put that answer on the test, that's acceptable?
Yep, absolutely. Yep. Okay, but it was easy only because I used second, hour, and minute as the name of the members, right?
Yeah.
If I name the members in different ways and out of order, then it gets a little bit more complicated, right? So I'm going through this math here because this type of reasoning will still work even if I don't give you the clue of, oh, this is actually the number of seconds, this is the number of minutes, and this is the number of hours. But you're absolutely right. I mean, if you trust the labeling of the members, then the conversion can be done without knowing much of this stuff.
I trust in you.
Yeah.
Yeah, but remember, the test is supposed to be not so easy, right? In other words, it can be a conversion from millimeters to yards into feet and inches and fractional of an inch or something like that. But it will still be the same kind of math.
So looking at it mathematically,
Right.
I was able to do 12 times 60 to the
12
0 power.
plus.
12 times 60 to the 0 power. 53
All right.
times 60 to the first power.
Yep.
And then 1 times 60 to the second power.
Yep. That's it. The other way to look at it. Yep. All right. So are there any questions about number 6 and number 7? What?
The N3.
N3? Okay, so by the time we get to this part here, we know that the number of the seconds has to have a value of 53 times 60 plus 3600 plus a number that is from 0 to 59. That is the only part that is left to be determined. Is that okay? When we know from the equation itself, from this particular expression, we know that seconds has to be in the form of 12 plus some kind of integer times 60. Is that okay? Okay, so now you have to look at this expression and then look at this expression here and say, okay, what kind of N3 will work in this case? N3 has to be an integer. Okay, this cannot contribute to N3 because it is a number from 0 to 59. But this part, if you use the distributive law, then you can re-express it as 63 plus 53 and then the whole thing times 60. So that's how we figure out what is N3, and once we figure out what is N3, then the whole thing is known. Okay. The way I worked on this is not based on intuition, oh, I know how a second and minute and hour relate to each other. The way I work on this is just based on the math. Okay, give me the expression, and I should be able to deduce from the expression, a range of value that will make it work. Okay, and now we have 3 of these expressions, and trying to work with these expressions one by one to figure out what is the original value in seconds. Right. Any questions about this one? No questions? Right. If there are no questions, we are really kind of done with the practice exam. So on Wednesday, which is the 19th, we'll have our second exam, okay? And the questions will be kind of in the form of, question 1 to question 7. I have not quite decided on the number of questions. The more is not necessarily worse, because the more questions, the less it will hurt if you just kind of mess up on one question. Okay, so that is why it may not be a bad thing to have more questions. All right. So if there are no questions about this, we'll go ahead and move on to the next topic. So I think we were talking about modular programming. So we are on this particular slide, and we were talking about abstract data type. Okay, you guys still remember televisions, remote control, and all that stuff? Okay. So do you still remember what abstract data type is about? Can someone kind of tell me what is abstract data type programming? Okay, first of all, which concept does it relate to? Of all the concepts that we have talked about so far, which concepts does it relate to? It's something that we have seen already in question 7 and questions 6. Structures, very good. Okay, so it has to do with structures. Okay, so the question is, how do you hide the details of a structure from the majority of your program, and structure and organize your program so that only a small fraction of your program needs to know what is inside a structure? That really is the question. Okay, that's what abstract data type is about, is to encapsulate and hide the details so that if you decide to change the implementation of a structure, you have 0.1% of code to modify, and then the rest of the program can remain the way it is. Okay, that really is the whole point of abstract data type programming. Okay, but in abstract data type programming is closely related to the concept of modular programming. So what we'll do now is to take a look at modular programming, and basically find out, okay, what does it mean when we say modular design or modular programming? Now the modular design, this link here, is not related to only to programming. It is actually in the context of all type of designs. The first attribute of something being modular is reusable. Okay, things are reusable. Second one is well-defined module interface. So from one module to the other module, the interface is going to be very well-defined. It's not like it's this, that, and maybe something else. Okay, there's no such thing as and possibly something else. And also insulation from changes. Okay, if you change one side, the other side does not have to change. Okay, that's also one of the attributes of a modular design. So instead of going into actual coding, can someone give me another example of modular design?
Power supply in your computer can be modular.
Exactly. Almost everything in your computer is modular, okay, in terms of design. For instance, if I decide to change out my hard drive, okay, I go to Fry's, I find out, okay, it's using SATA, and my controller is capable of doing 6 gigabits per second, okay? And I go to Fry's and buy a new hard drive. Is there any chance that it may not work with my SATA controller on my motherboard? No. It has to work, right? And how does it fit into these 3 attributes? Reusable. Am I reusing my motherboard and the rest of my computer?
It's also well-defined.
It's also well-defined, exactly. Every single hard drive has the same SATA connector and the same power connector. Okay, it's definitely reusable. Okay, all my cables, okay, I can reuse. My motherboard, I can reuse. The only component that I'm changing out is my hard drive. Okay, what about the screws, the hardware that mounts my hard drive to my case? I can reuse those too, right? Okay, so that fits the first description of reusable. Everything except for the thing that I'm replacing is reusable. I know I sound like Daffy Duck today. I just reminded myself, it's like, oh, I sound like Daffy Duck. With less spitting, hopefully. Okay, and then number 2, well-defined module interface. Okay, is the screw specification to mount the hard drive well specified? It is. How about the locations of the mounting holes?
Yes.
Well specified. The shape and the size of the connectors? Well specified. The size of the hard drive itself?
There.
Well specified. No, that part is well specified as well, because otherwise you can end up with a situation where a hard drive is too long or too short, it won't fit.
The size, like in capacity.
Oh no, yeah, the physical size. Yeah. All right. How about insulation from changes?
Very.
Yeah.
Very. Yeah.
Exactly. So that's what modular design is about. Okay. So you can think about a world when things were not designed in a modular way. Okay. Every time you change your hard drive, you might have to change your motherboard. You might have to change all of your cables. It may not even fit in your case, and you may not even be able to reuse the screws that you actually attach your hard drive to your computer, to the case of your computer. Okay, that would not be desirable, would it?
But it's gonna be more profit for the companies.
Until no one buys, from that company anymore. Let's see. Well, I think that's how Macs used to be, right? Everything, they have their own standard on everything. It's not the same as everybody else. Well, these days they are now pretty much consistent with the rest of the world. Except for that iPod connector thing. That is still an Apple thing, right? All right, so, but in terms of programming, we also want these attributes in your programs, okay? So that means, what is reusable in programming? That means instead of using copy and paste, code that is commonly used somewhere, everywhere, is going to be extracted, and we want those to be reusable without having to copy and paste and modify. And that's why we have functions. Okay, functions is the most basic way to reuse code in programming, but it's not the only way, or it's not the best way to do it when you're dealing with C++. If you're dealing with C, yes, okay, functions is pretty much the only way you can reuse code. Macro to a certain extent can do it, but it's not really a good way to do it. But functions is the only way you can reuse code in C, in regular C. In C++, there's a thing called a method, which is kind of like a function inside a structure. That really is another way to reuse code. And then when we do get to the point where we talk about classes, inheritance is another really fantastic way to reuse things from one module to the other module. Well-defined module interface. Now we are dealing with, if you're dealing with functions here, that means we're dealing with the return type and the type of the parameters of a function. Okay, so we want to make sure those things are quote unquote clean and well defined. Okay, it's not wishy-washy like we might want to add one more parameter here. You fix the subroutine to have a particular return type, a particular number of parameters, and the types of the parameters, and you don't change them. Okay, if you're going to require something different, like you need one more parameter or one fewer parameter, you make a new function. But you don't change the functions that you have already defined. Is that okay? So this way, there's no change that will necessitate from the perspective of the caller, which is basically what you want to avoid, is to have to change the callers all day long because you change the way a function works. Insulation from change. Okay, same thing. It means by carefully defining the functions, a change of the implementation, which is how you define the structure, should not have impact to most of the program itself, and only have impact to a very well-defined portion of your program. So the way to do it, I think I just went over some of this already. To make a function as flexible as possible is if you look at a function and you have some kind of constants, like for I goes from 0 to 5, okay? Really, should that be a 5 constant, or should it be a parameter that is passed in so that people can specify a number other than 5? Okay, so whenever you have constants, numerical values that are spelled out in a subroutine, that's one thing for you to think about is should I parameterize that particular value? Okay. In a subroutine, also do not use global variables. Use parameters. Whatever you need to know inside the subroutine, don't use global variables for a subroutine to know something. Whenever you want a subroutine to know something, pass a parameter to it. Are we doing okay so far? Okay, but what if I'm dealing with a subroutine that needs to know like a gazillion things, like 200 individual little items? Sorry? You can use an array, but you can also use a structure. Okay, so depending on how those things are related, you can use a structure. So if you use a structure and all of those things are actually related, they belong together, then you have these gazillion things or 200 things kind of packed into a complex structure. Yes, you still have 200 individual members eventually, but guess what? You can look at those 200 individual components as one single structure, and when you pass the parameter, it is one single parameter. It's not 200 individual items. as parameters anymore. Okay. Okay. Programmers often resist doing this, meaning avoid using constants inside the subroutine and do not use global variables. Very simple things to ask, but most programmers don't like to do that because it does make a function, quote unquote, more complex because you end up with more parameters. A function with many parameters present its own set of problems, which means if you pass the wrong parameter or if you pass an argument to the wrong parameter, the compiler cannot catch it. To deal with this, we can use structures to package related parameters into larger units. And this is actually done in system programming too. Okay, all types of programming make use of this particular strategy to limit the number of actual parameters. Okay. So the concept of using structures eventually lead to object-oriented programming, which this class will touch on, but it will be expanded in cisp 400, which is object-oriented programming. This approach, meaning using structures, also has the advantage of you can change the structure all day long, but it won't change how the subroutine is called. Okay, let me just illustrate exactly what I mean by that, because sometimes we look at this and go like, yeah, but oh, you know what? I can just use Q7 for this purpose. Okay, so let's just say that at some point I say, you know what? Using hour, minute, and second is not quite enough for me to represent the time, because for whatever reason, this particular application needs to keep track of time at a millisecond level. Okay, and I don't want to turn seconds into a floating point number because floating point numbers are pretty hard to deal with. It chews up a lot of processing resources on certain platforms. So what I'm going to do is to say, oh, you know what? I want to represent milliseconds too. Milliseconds. Okay. Is that going to change the way I deal with seconds to HMS? At least the way it's called. Nope, it's not going to change it. Okay, if I change the representation of time to include milliseconds, I can keep the subroutine call second to HMS. The only thing I need to add to this one here is to say, you know what? Because whatever is told me is only in seconds and not in milliseconds. That means the millisecond member is going to be a 0 because we're dealing with just number of seconds here. All right. Now, this is the subroutine that has to know the structure of a time. What about this part here? This is the end user. This is the consumer of that subroutine. Do I need to make any changes here? No. Sorry?
If you were going to pass milliseconds, then yeah.
Yes, but in this particular program, I'm only counting in seconds. And as such, even though I change the structure, I don't need to change the way I call the subroutine because type time or type struct time is still type struct time. Is that okay? Now, I did violate one of the rules if I were to adhere strictly to abstract data type. I did break one of the rules because the main program refers to hour, minute, and second of the structure. If I were to do abstract data type programming, I should stop doing this kind of thing. So what am I going to do without these things? So what you need to do in this case, if I want to hide the entire structure from the main program, I'm going to have the additional subroutines. One is just going to call get second, and you will pass a struct time. In this case, it will pass a const struct time %t, the const to make sure that I don't accidentally change anything, and then the ampersand or the passing by reference makes it more efficient. And the only thing it does is to say return time dot second, and I will have 2 or 3 more of these things for the other 3 members. So I am copy and pasting here. So one would be called get minute, and the only thing it does is to return the value of the member minute. And this one's going to be, you guys know the drill. I mean, this is just hour, and this is going to be millisecond, millisecond, and it will return the value of the millisecond time. Now, it doesn't look like a big change. It sounds like, oh man, you're going through all this trouble just to get to something that's easy, right? Because now, instead of using t.hour, I can say get hour of t. Instead of saying t.minute, I can say get minute of t, which is a structure. And now I can say get second of t. All right. That really sounds like a totally unnecessary change that doesn't seem to have any advantage in this particular program. And you are absolutely right. It has no advantage or no real advantage in this particular program. But what if I have a program that needs to refer to the hour, minute, and second at 2,000 different places? It still doesn't make any difference, right? I mean, t.hour, t.minute versus get hour, get minute doesn't seem to make any difference. Now, think about this. What if I go to here and go like, I don't like this representation of time anymore. I'm going to use the star date format from Star Trek. Right? Now I have a big problem, don't I?
Yes.
Because I got several thousands of references to members that are no longer in existence. But tag, you're going to have a problem anyway, right? Yes, I have a problem anyway because second to HMS has to change. Get second, get minute, get hour, get millisecond. They all have to change because now instead of just returning the value of a member, I have to do the calculation based on the star date representation. I have to go back and say, okay, what is the equivalent minute, hour, and second? But guess what? I only have to make that change once. And all the 2,000 or 3,000 references to get the hour, minute, and second out of a time representation, they can stay the same. Yep.
Isn't it because it doesn't matter what you name it, as long as the order is correct of what you have inside of the, like, get milliseconds inside of those parentheses of them, like.
You mean the parameter?
Yes.
Yep.
Pretty much having.
It's just one type, right? I can change the structure all day long, and I have to make the matching change here. So it will still be returning the number of seconds based on whatever time representation I choose to use in the structure. But the rest of the program, which is in this case, which is not a whole lot, this does not need to change, and these do not need to change as well. But in a real program, there will be like thousands of these things and only a few of these things. So by using abstract data type programming, I'm now insulating the 2,000 uses of a time structure from the changes to the implementation or the details of the structure itself. So is everybody kind of seeing the advantage of using abstract data type programming? Okay. Is the compiler going to complain if I just switch back once? Okay, I'm just going to sneak by, here and say, so at one point, I'm just going to forgetting that I'm supposed to use abstract data type, and I go back to say t.second. Do you think the compiler is going to come back and slap my little wrist and say, "Tech, this is bad. Go back and use your abstract data type, functions"? Nope, the compiler doesn't care. Okay, either way is quote unquote correct. Okay, we are running out of time, so I cannot tell you how or things they can do to make the compiler complain and chew you up when you do not use abstract data type programming. So we'll continue this next Monday because on Wednesday we have an exam.
Tag?
Yep.
I have a question. Remember